So I've now worked in the biomarker field in neurodegeneration specifically for about 10 years. I started work at UCL with Professor Henrik Zetterberg in 2012, where basically funding became available to kind of draw together all the different aspects of research into neurodegenerative disease, which was never really, a whole thing at UCL at the time. And so their money was spent on PhD programs and imaging programs. And one of the programs was biomarkers. So we kind of started from scratch, sort of setting up a laboratory and plans of how we'd move this research forward. About 10 years ago, we were still very much looking at the right way to measure biomarkers. And that was exclusively in cerebrospinal fluid, because it makes sense that you measure brain proteins in the fluid that surrounds and bathes the brain. So that's good. They're also at high enough concentrations in the brain to be able to measure them in there. So that's what we spent, a few years doing, setting that up, and also setting up facilities whereby researchers at UCL in our field could biobank samples, because it's actually quite a difficult thing if you work in an academic space to get your samples looked after properly, or even anyone to know how to, what to do with a CSF sample when you get it so that you can use it in years to come for research. And at the time also lots of people were starting to bank blood samples as well. We didn't do anything with them at the time because we couldn't. There wasn't any kind of proof that we would find blood-derived biomarkers, brain-derived biomarkers in blood at that time. However, prospective studies are just that. You study and you bank samples for discoveries that are yet to be made. And so we spent a lot of time refining biomarker measurements on CSF, and B, banking samples for future. And then in about 2015, it came to our attention that there were new technologies being developed that were much more sensitive. And it looked like there might be a case for being able to measure certain biomarkers in blood, which was really, really exciting. And actually, I think really, really, a lot of people were quite skeptical about it and didn't really believe it. But more and more evidence started coming out that this was actually true. And so we applied for grants to invest in this technology. And we did so, and we were successful, and kind of slowly started building up collaborations with people in the field to measure samples. And in that way, you get a body of evidence to show that, in fact, you can measure. And the first protein that we realized it was possible to measure was neurofilament light, it's a protein that isn't specific to any disease at all, but it is a marker of neurodegeneration. And that's what we're looking at. So that's really, really quite important. That first kind of breakthrough in the blood biomarker field, I think, led research by companies, etc., into what other markers could we measure, and could we prove that they were related to what was going on in the brain. And so since then, a number of different proteins, mostly associated with Alzheimer's disease, to be honest, amyloid proteins, tau proteins, tests have been developed that we can use on blood. Our capacity grew, so did the demand for that capacity. And we don't just collaborate with people within the DRI or UCL, but with labs all over the world. So we get samples in almost daily from everywhere, basically. And so it was just before, in fact, it was the Friday before we went into lockdown, myself and Henrik had a meeting with Bart de Strooper and Adrian Iverson at the Dementia Research Institute HQ to talk about the Biomarker Factory, what that could be and what the plans for that would be. April 21, we were awarded the funding to be able to employ a technician and a facility coordinator, as well as, I mean, I'm already there, so that's fine, and get another super sensitive assay machine and set up the biomarker facility. And so 1 year later, a year and a half later, we're now moving into phase 2 of that program, because we've actually grown, the demand has grown. And so we're now looking to get another technician and another machine and sort of keep growing.